social media and spread the security message. So my name is Natalie. I studied computer and software engineering. I loved the university classes on parallel programming, and I started writing Go code back in 2014 when I moved to Berlin. So the story is that I studied hardware and I really loved it. But when I moved to Berlin, I realized that this is a country of software. So this is what I had to do there. And that found out actually to be pretty nice, because in hardware, the classes that I loved most were about massive parallel programming, for example, with CUDA and, playing with GPUs. And I was dreaming to go to NVIDIA. And Go is actually not that far off from that. It's pretty similar. So that was a pretty nice surprise or change for me. Even though that professional-wise, it was a really big jump from working on chip design in Intel to like going to some 20 people startup, everybody does the same, everybody does everything, and definitely different. Cannot say I don't recommend, definitely do recommend. And so after some time of doing Go, I attended DEF CON in 2017. DEF CON is the world's biggest security event that's taking place in Vegas. And the nice thing about it is that everybody can attend. So you buy a ticket upon arrival, and that's how they end up having 25,000 people there. And that's 72, I think, 96 hours event, in the sense that it's not a conference from the morning until the evening and then there's a social event. There are tons of things happening very intensely at any given time, whether it's in the morning, in the evening, or 3 a.m. Always hacking, always trying to do, whether it's hardware, whether it's software, and that place really blew my mind. I realized that there's a whole fascinating world that I was missing. And I never ended up changing careers, but I did stay very curious, and I am going to do CTFs, and I am attending the Chaos Communication Congress, and I can recommend you to do the same, because it's definitely eye-opening to learn how exposed everybody is. Now I started working as a developer advocate at Aerospike, which is a database company. And the reason that I like them so much is that they are very SRE focused, in the sense that some companies have the system deployed for 8 years without ever having a downtime. They have cross data center, and they have really fast transactions. I actually got to know them from one of the companies that I worked at the past, that they did online bidding on stuff, and they had to respond within 100 milliseconds. And that database was really perfect for this type of requirement. The code base is written in C actually, but there is definitely a client in Go. And in my previous job, I used to be an engineering manager in a Berlin startup called Frogster. And the interesting things about being engineering manager in a fintech company was that we had to undergo all kinds of trainings, for example, on how to be PCI compliant. Now, PCI compliancy means that basically you have the permission to store a credit card number of people, and you go every year through a really long, like a week-long audit, where a person comes and asks you questions. How are you doing this? Why are you not doing that? How are you doing this? And basically in the end they say, you either need to improve or I think you're fine. And a recent requirement in that company was that with all the practices in place, we also had to put the entire developers team under code training annually, teaching them about security best practices. This is actually how the idea to this talk showed up. And a lot of what you'll be seeing here today is exactly this. So this is basically best practices from the previous workplace, and I hope that this will be educational for you. I should also say, sorry, that was jumping too fast. I should also say that security is a field that's changing fast. And while this is relevant for today, some things may not be relevant in 6 months, definitely not in 1 year in the future. So when you go back to this recording, some things are the same, but do make sure you catch up to whatever developments happen. I also want to say a special thank you to Elena Grachowicz from Berlin and to Baruch Sadugowski from California, whose talk I based this one. And I want to thank everyone who reviewed this talk and gave me feedback. Many people looked at it, many people contributed, and for now I can say it's in a decent shape. So let's start. The first thing that usually mentioned in the context of security is a traditional 7-layer model. In this talk, we'll focus on 4. We'll talk about how to secure the data, how to write to secure code, how to keep dependencies secure, and we'll finish with talking about containers. Data. What's the first thing that comes to mind? It'll be an easy one. Passwords. Passwords should be encrypted, right? So if your user is providing the passwords, you can let the database encrypt them. That's a good idea. What happens if you need to generate them? You should use some random function, right? So who's familiar with Go code? Raise your hand if it's a yes. Are you familiar with Go? All right, so you can look at it and tell me if you think that this will be working or not. If you think this is a good code, raise your hand. No hands, okay? That's indeed so. It's actually not really random. And the reason is that our seed here is a constant. So generate a random from a constant, you're not going to get anything different. That's actually why when you use the Go playground, you get the same random. All right, let's initiate with time instead of with a const, right? So now we have something that is not a constant. Is this a good solution?
No.
If you think this is a good solution, raise your hand. No, okay. The reason is that if you see here in the middle, I hit enter fast enough for this to be not really random. Now, if I can do this fast enough, the machine can definitely do this fast enough. So it's really not a good idea. Another reason this is not a good idea is that if somebody will try to hack you and they will try to imitate the way that you're generating passwords, using time is like using the password 1, 2, 3, 4, 5, 6. Okay, so who thinks this one is a good idea? Here we're using the library crypto/rand, and we're generating a random based on that library. Will crypto/rand give us good results? Raise your hand if yes. No. Actually, it is a good idea. Crypto is random indeed, and putting aside blockchain and whether we have good or bad opinions about it, it does generate random answers. So that's a good choice for us. But raise your hand if you're familiar with the crypto/rand library. No, okay. Ish, is there somebody in the back raising their hand? Cannot tell if I see that. Okay, maybe. So even in past times that I gave this talk, the people who were familiar with this library generally were not familiar with what it does. So I can tell you that what it does is it's called the Operating System's Cryptographically Secure Pseudo-Random Number Generator API. Pretty long, pretty complicated, and the scary part is actually few people know what this thing does. All right, so the next thing we have is user personal data, like email, like address, credit card numbers. And logs, they show this private data, and they can leak. And you should make sure that you stay safe already on the log level and mask your logs, because a common problem or the weak point here is basically that the developers can be the human factor that is breaking your security. And you want to keep your developers secure, let's say, from even being in a situation where they can compromise your data. So tools like Sumo Logic, what they're doing is that they're masking part of the data. Another example is Splunk, another example is Fluentd, and even Elastic. So all those tools, what they do is in different variations based on the user permissions, they hide the content of the log. So basically the developers can still look at the logs and say working, not working, without being exposed to the user's email or phone number or other personal information. Secrets management. We talked about data leaking from logs, but how about secrets? So what is the easiest thing we can tell about secrets? Don't store them in your code. There's so many passwords that you can find just by Googling. Okay, you made a mistake, you accidentally put your code there. How are you going to fix that? The answer is not by simply deleting that. Simply deleting will not help. That's the entire point of the revision history. And if you don't nuke anything from your history, it really only does get worse. But some good solutions are, for example, Kubernetes, right? Raise your hand if you're using Kubernetes to manage your secrets. 2. Okay, I'm curious, the people in the back, what are you using? For any specific tool, or you just like somehow a local config file? Okay, never mind, you can tell me later. So the people who are using Kubernetes to manage the secrets, I have some questions for you, or remind you that this is a yes. Keep your hand up if you want to say yes. Do you know how the secrets are stored? Do you know who can access them, who can modify them? Do you know how can you know who accessed it? How are they transferred to the application? Let's zoom in to the documentation about the part of using secrets as environment variables, which is a common practice. And anybody is doing that? Okay. When you will have the chance, take a picture of this and type it in your machine. Or if you happen to be the DevOps person or the engineering lead or something, go to some laptop of one of your colleagues and try to type this, see what you get. If you have your permissions in place, you will not get any surprise, but if you don't have your permissions in place, what you see is that anybody can see anybody's secrets. So if you want to take a picture, this is the chance. All right. An alternative is a dedicated secret management tool, for example, Vault by HashiCorp. It is open source, it is written in Go, and it has a pretty straightforward SDK that you integrate into your app, and then you get the environment variables, the secrets not as environment variables. And next, we switch to code. So I talked about keeping the data secure. Now let's talk about keeping the code secure. And input validation is usually something that people are pretty conscious about when it's a microservice that they're building and you're exposing it. You will check for buffer overflow, you'll check valid ranges and so on. But are you doing the same when you're looking, when you're building a microservice as a backend person to your front end? If you're using a third-party app, when you're taking it to your code base, are you checking it before you're agreeing to use it? If you're using somebody else's code, do you assume that they're doing smart things with it? So if you are writing code, I would recommend you don't assume the microservice will remain internal. It can be open sourced, it can be used suddenly 1-2 years in the future by another person who didn't read your documentation, even if you even wrote that. So make sure that you, for whatever microservice you build, you do it safe, and basically assume that your user is a troublemaker that doesn't know what you're doing. SQL injection. So back to DEF CON, what I did there was a newbie training, and one of the first things that they do there is tell you about like really basic things that you can do as a hacker, as a beginner hacker, and SQL injection was like probably the second thing there. And you think that all the websites by now will be safer, right? But it's actually still a vulnerability that's found again and again. And let's look at a code example. Does this look right to you? Raise your hand if yes. Here, you can see injection in the very first function. We actually can get anything as a name here. The solution is to escape variables, put them only in the sanitized form in the database. Use name parts to provide number of parameters and make sure that the SQL driver will check you if you're safe for injections. There are tools that can check for things like the SQL injection and the random number generator and many other ones as part of your static code analysis. And one of the most popular one for Go is called GoSec. What it does is it inspects the source code and it uses it as part of the CI. It helps you understand how your code works, and running our previous code through that, this is the result. So it found the injection and it found the weak random generator. And the reason that the first one, the weak random generator, is confidence medium but severity high is that you will definitely use it. That's why the severity is high. But the SQL injection only gets severity medium because there is a chance you will not use that if you're not using the new user password. If you want to block certain libraries, for example, the math/rand, you can use a tool like depcard, which is an open source Go linter that checks if the package imports are in a list of acceptable packages. So you can make a blacklist locally and you can say, use that, don't use that, and it will basically be part of the CI. Depcard is a linter that was built with Golang CI lint in mind, and it's compatible with the documentation of it. And it's a linters aggregator. So in addition to add those things, you can add also a bunch of other linters there. For example, internal code or styling guidelines. It's pretty easy to integrate and it has a low number of false positives. But the problem with linters is that you need to remember to run them. So better automate, and with a tool like this, you can just not say, hey, I remind you to run this linter with a tool, but it's actually part of the build. So pretty nice. Okay, who here uses pprof? Cool. Makes profiling easy. It's a pretty great tool. And let's look at this small piece of code. The second import is what you need to add profiling to the app. And you practically don't need to add almost anything else. And once you expose your server with doing HTTP listen serve, it will also include the profiling in everybody who accesses your API. Ouchie. So let's rewrite the code in a smarter way. An easy way to do this is to have different handlers for different purposes. Right, so not just one handler, the general one that has some business logic and also the profiling, but one for, or a group of endpoints for internal health checking, including profiling, and a set of endpoints that is only open for business logic. Another way you can go about this is also playing with the rules, for example, on Nginx, that only internal traffic can access things like profiling and other local health that should not be exposed to other people. And the motivation not to expose to other people is not that they will not include you in their benchmarks, but because knowing your limits is the way to find what's your vulnerability. That's also how CTFs work. And this brings me to this joke that a QA engineer walks into a bar, orders a beer, orders 0 beers, 999999999 beers, or there's a lizard, -1 beers, and a blah. That's how you do QAs, that's how you do CTFs. So yeah, fuzzy testing, the last recommendation. Next one is the funniest and the saddest part of this talk, dependencies. So we said that dependency is somebody else's code. And one thing is when you use a standard library in Go, but how about third party? Should you trust random pieces of code written by strangers on the internet? From you not raising your hand, I'm assuming you want to say no, but actually most of us are already doing this. So maybe the answer is yes. Okay, so you trust your dependencies. How about your transitive dependencies? So the dependencies that your dependencies are using, the imports of the libraries that you are importing. Everybody's using this library, so it must be safe, right? What do you know about your transitive dependencies? Like, can you think of how many of those you have, or name a few? This is a picture that I took earlier this year at .go. It ruins many people's day, and what you see here is Dave Cheney asking people in the crowd whether they're sure that this crypto library that they imported doesn't have this part that basically nullifies an error check. So here's the suggestions for some questions you should ask before putting random dependencies into your system, aka the checklist. So what is the code quality? Is it good? Is it secure? Do they check for SQL injections? If there's no test coverage, you can assume that it will be not safe in production. How active is it? Is it abandoned? If yes, how can you be sure that security patches are being added? Because vulnerabilities and everything are being found all the time. Who are these maintainers? Are they trustworthy? Are there enough of those? And is it written in a secure manner, or are endpoints exposed things like profiling? Is it licensed in a way that will keep you safe? All this and a more comprehensive list is available on this link. I very much recommend to take a picture and go back reading it. It is made by Russ Cox, which is a member of the Go team, and he discussed this in very detail earlier this year. Okay, now we'll see 4 examples of the past where people did not ask these questions and how did that end up. The Equifax breach. Has anybody heard of it? Equifax is one of the biggest organizations in the US that basically saves your social security information. So your kind of ID number, and once somebody has that, it's very easy to impersonate. This is one of the deepest security breaches of the time. And over the course of 4 months, hackers retrieved 148 million records of personal information from this credit scoring institution. And what happens, basically, this is a huge organization with a lot of legacy code. They're using Apache, and they got a notice that a patch needs to be made if you're using it, but they did not know that you're using it, and they also had no idea where are they using it. So they took 4 months to fix that. So in this example, we learned that just safe dependencies is not enough, because Apache is safe, it's great, it's highly maintained. But if you're using it in a way that is not safe, so you're not keeping up to date, you expose yourself to vulnerabilities. So know your transitive dependencies that you have. In smaller systems, it can happen that you don't know that you're using a specific library in a transitive way. So the dependency or your dependency. In huge systems, it can be that you don't know that you're even using a specific library. So the time that they needed to understand that they're using Apache was 4 months, or know that they use that and fix it. Continuously monitor new discoveries. Somebody needs to tell you that you need to update, and there's tools for that. One good tool is called Dependabot. It's for a while integrated actually into GitHub, and there is an equivalent tool that is integrated into GitLab. And what it does is that it opens a pull request to keep your dependencies up to date. Basically, whenever a dependency that you have has a new version, it opens a pull request and it says, here's in green and red, you can see the differences. And if you want to merge it, click here. If you want to make any changes, just we brought this to your attention. It also supports Go, and it's free for open source software. Upgrade swiftly. Once you know that you need to upgrade, do it fast. This means that you need to have the infrastructure to do this. So if you work for a company that releases only every other week, you need to be prepared for such a situation. And you also need to think, in case you're a larger organization, whose responsibility is it to do it? Right? If you have a tool that several libraries, that several teams are using, is it one of the teams going to do it? Is it the ops team going to do for everyone? Because different teams being on different versions can sometimes cause the problem of not being coherent with each other. So make sure that once one team says we need to update, all teams will update. Next example is a crypto coin that was stealing your data because it was in JavaScript or in a specific JavaScript library. So this maintainer decided that he's done with a specific library that he was doing and gave it to another person. The another person immediately put in this code that steals crypto coins for people. And so many people lost their Bitcoins and other crypto coins. Do you remember this?
Yeah.
It happened just last year. So what are our takeaways? A single maintainer is not safe. Maintaining open source code is really the worst job. You work for free and most people just come complain and say, can you do this? Can you do that? So once you get tired of it, you need to be in a setup that you have a backup, that you have another person that you already trust that can take over for you. Automatic upgrades can have risks. We talked about Dependabot opening a pull request whenever you need to merge it, whenever you need to update something, but it doesn't do it automatically. Because imagine Dependabot or any other tool would be automatically putting this code into your software. You definitely want to sue them for that. And it's true, because auto upgrades can be dangerous. You don't know what's going into your code base and you have no control over this. Lock the dependencies versions. Don't update before you know what's inside. Next one is from 3 years ago, when there was a specific JavaScript library that what it does, it's 11 lines of code that pads spaces from the left, because you need that for many frameworks in JavaScript. And obviously you need a library for that. So at some point, the person who's maintaining this said he doesn't like the NPM, the central repo anymore. He pulled it from there. Millions of websites crashed. And the reason for that is the way that NPM works in JavaScript. So whenever you pull for updates, it takes the most updated version from the central repo and it updates it in your local version. But if it was removed from the central repo, it also removes it from you locally. And so imagine that you wake up one morning, hit, okay, check dependencies, suddenly your website down and you have no idea because all you did was update the version. What are the takeaways from this? Immutable dependencies are a must. Take any step that you need for this. You can do vendoring or you can use the new Go modules where the proxy supports it. Central repositories can be risky. So if you choose to use that, know that you have to be taking an extra measurement of safety. And the last one, and the scariest one, is from just last year. And it was from a person who was having also some code, and they don't like the ICE. So the Immigration and Custom Enforcement Organization of America. You probably hear about them right now because there's some buzz on the social media on whether companies should or should not collaborate with them. The person behind this definitely did not want to collaborate with them, and they decided to fight ICE by making companies that collaborate with them being permitted from using the library. For example, you see here in this PR, like Microsoft, like Palantir, like Amazon, and so on. The new license clearly stated that these companies are not allowed to use it. And you know the consequences. If you're one of those companies and you're using this license, you're open to lawsuits. This change was accepted and it was merged. And that's not all. The person behind it wanted to make sure that this change happens without changing the license name and without the major. So major version, which is the acceptable approach in open source code. Now, imagine you're a person who's working in Amazon or Microsoft or Palantir. You wake up in the morning and you do, okay, let's check a version. Oh, new version, okay, add the update versions. And from here to there, you brought your company to a situation where they use a license that says clearly Microsoft is not allowed to use this license. Now you're just one engineer, you open your huge corporation to a huge lawsuit. You don't want to be that person. This was also merged, but luckily it was quickly reverted. And the takeaways is that licenses can be as complex as security issues because we saw why. Minor upgrades also need attention. It's not likely, but it's just an agreement. This is not the law. It took people time to realize that what that person did was sneak in this change without correctly updating the version. You don't want to beat the odds. Be careful when you're updating. To summarize, we saw 4 examples. We saw how the Equifax breach happened because it took too long to patch. We saw how a JavaScript library was stealing crypto coin from people. We saw how another JavaScript library that was padding 0 broke websites because it was removed from the central repo. And we saw how a small version update almost exposed huge companies to huge lawsuits. And to summarize the takeaways, that's how you can be safer when you're using dependencies. Control your dependency tree. Not just the dependencies, but also your transitive dependencies. Be careful when you're adding new ones, and continuously verify your dependencies. Carefully read before the version update, major or minor. Always have a reproducible build, so just relying on safe and confirmed dependencies. And upgrade dependencies quickly. It has bug fixes, it has security fixes. Do be aware of what this includes.
I'm sorry, can you open the slide? We won't take a picture. Thank you very much. Thank you. Thank you.
Do we have time for questions?
I have a question. Do you face that problems that you listed to us in your real work? For example,
If I face the problems,
yeah.
I try always to learn from other people's mistakes. It's always easy.
Great.
If you have more questions for me, you can also tweet on later. It's completely fine. Happy to answer. More people will join the answer if you do this publicly.
Thank you.
Thank you.
Всем спасибо. На этом метап закрывается сегодняшний.